This is Chandan Chakraborty from Kolkata. I am a statistics teacher and also teach computers. This is a die. I will today teach you about probability. I'll throw the die. The result is 4. So the outcome is 4 and this throwing of the die is called random experiment. Now if I throw here taking another die, here is starting there is a sum of 3 plus 1, that is 4. Now I throw, the sum is 5 plus 1 is equal to 6 and so on. The probability of getting a sum of 6 is, is 6 has come already, is 1 by 6. Can you understand? Let us see. Before that, let us go to the chessboard. There is chess clock. There are 64 squares here. Out of them, 32 is white and 32 is black. So, if I close my eyes and put my finger into randomly into any place I am closing my eyes, then the probability of getting white or black is nothing but 32 by 64. But why? Because there are total 64 squares are there and out of them white squares are 32 in numbers also. That is true for black squares. So let us go to the whiteboard to write something. Can you see? Let us adjust a little bit. I am taking a pen to write the classical definition of probability. Classical definition, okay? The classical definition of probability, okay? You know, it is the probability of any event PA is nothing but is equal to m by n, where n is the total number of mutually exclusive, exhaustive and equally likely cases, out of which m are favorable to the event A. Let us define those terms like events, outcomes, random experiment. Number 1, random experiment. Random experiment is just you can throw a die. Okay, you can throw a die. The result or the outcome is not known. What will be the result? So if you throw this die or roll this die, the result may be anything. That is 1, 2, 3, 4, 5 and 6. So the totality of the outcomes, these are the outcomes 1, 2, 3, 4, 5, 6. So there are 6 outcomes. The totality of the outcomes is called the sample space S. Let us see another thing, that is number 2. So in 1 we have learned about random experiment, the experiment whose results are not known, but we can know the all possible outcomes. But in a particular throw, what will be the result we never know. We cannot predict. This is random experiment. And the sample space is the totality of all outcomes. And outcomes are the result of each experiment, particular experiment. So 1 turned up, so 1 is the outcome. Now I am going to point number 2 about outcomes. Outcomes may be what type of? Outcomes may be combined to form events. So outcomes may be combined to form events. Let us see what is that. Let us define an event of getting odd numbers odd numbers, okay? Getting odd numbers in a single throw of a die. So the odd numbers are 1, 3 and 5. 1, 3 and 5. These are the odd numbers. So the event A may be written as the collection of the outcomes 1, 3 and 5. So again, when outcomes are combined in numbers like 1, 2, 3, 4. So here are three numbers of outcomes combined. We get the events. And simple events are nothing but a single outcome. Say 1. 1 is also a simple event. And composite events are nothing but the collection of more than one outcomes. Here A is a composite event. But B is the event of getting 1. Event of getting 1 is a simple event. Now, what type of events we can get? Number 3. What type of events we can get? Let us see. There are terms like, say, mutually exclusive events. Mutually exclusive events. Okay? Let us see what is mutually exclusive events. 2 or 3 events are called mutually exclusive if they can't occur together. For example, along with the event A, we can take the event B, which is the collection of even numbers like 2, 4 and 6. So, so A and B can't occur together. They are mutually exclusive. In any throw of die, you can't get both of them. So they are mutually exclusive. For better clarity, let us define another event C, which is defined as the collection of numbers we have got in a single throw of a die which are divisible by 3 only. So divisible by 3 is 3 and 6. Now you can find that B and C are not mutually exclusive. But why? Because B intersection C is not is equal to 5. Not is equal to 5, or the null event is here 6. The event, another event. B intersection C is another simple event. So B intersection C is not equal to 5. So repeating once again, what we have got? 2 events are called mutually exclusive if their intersection, that is A intersection B, is equal to 5. This is the definition of mutual exclusive events. A and B will be mutually exclusive events if we can get like that. Okay, you can try different examples of your own. In Venn diagram representation, we can see that it's a rectangle, the universal set or universal collection of events. If A and B like that, they have no common item, they have no common outcomes, then they will be called mutually exclusive. And if A and B are like that, that is, they have some common items like these and this, they have some intersection null part. This is, they are not mutually exhaustive. It's clear. I think it's clear now. So this is the diagram of mutually exclusive events, and this is the diagram of not mutually exclusive event. Now, since in this experiment these outcomes, it is supposed that this die, let us take the die. Okay, all the outcomes have same chances of occur. So all the outcomes have same chances of occurrence. So in this case they are called equally, you see here, equally likely. Okay, equally likely. So all the outcomes are equally likely because this die is a balanced die. Okay, now we have come through the terms equally likely, mutually exclusive events, and now we will come to the term of, say, exhaustive events. Exhaustive events, okay, it's exhaustive events. Now we are exhausted, no? We frequently says after doing some hard works, we become exhaustive. It's E, okay? It is exhaustive. I'm taking mobile in one hand and writing in other, so please, sorry for the convenience. However, exhaustive events is that it totally, the sample space is totally exhausted. Here, for example, take the events A of odd numbers, this is odd numbers, and B the event of even numbers. So if we take A union B, then what we get? We get like that, the total sample space. Understood? See it again. A is the collection of odd numbers 1, 3 and 5, and B is the collection of even numbers. So A union B, the totality of A and B will be, you understand, is nothing but the sample space 1, 2 up to 6. So in case of exhaustive events, no other elements or outcomes are left in the sample space. Okay, so the term we have learned is exhaustive events. So telling again for your convenience, equally likely means that the some events has equal chances, outcomes has equal chances. Here mutually exclusive events means 2 or 3 events cannot occur simultaneously. Now exhaustive events means that union of the events, a collection of both all the outcomes of 2 events gives us the totality of the all outcomes, that is the sample space. Okay, depending on this, we will now try to actually define probability, and the definition will be classical definition.